PySpark Online Training. Learn best online training with expert and upgrade your skills with new knowledge. Introduction to PySpark. The vast ocean of data beckons, but traditional tools simply paddle around the edges. Enter PySpark, your powerful ship for navigating the high seas of big data, propelled by the winds of Python and the currents of Apache Spark. In this introductory voyage, we'll chart your course through the basics of PySpark, equipping you with the knowledge and enthusiasm to embark on your big data adventures. Core components of PySpark. Unveiling the powerhouse, core components of PySpark. PySpark, the Python API for Apache Spark, empowers you to tackle big data challenges head-on. But behind its seamless interface lies a symphony of powerful components working in concert. Let's delve into the heart of PySpark and explore its foundational elements. 1. Resilient Distributed Datasets, RDDs. Imagine data split into distributed, immutable chunks spread across a cluster of machines. That's an RDD. These fault-tolerant units enable parallel processing, handling failures gracefully by recreating lost data. Think of RDDs as the building blocks of PySpark, offering transformations like filtering, mapping, and joining to manipulate data efficiently. 2. Data frames. Craving a more tabular structure? Enter data frames, representing structured data organized in rows and columns. They offer familiar data frame-like operations for filtering, sorting, and aggregating data like you do in Pandas. Data frames offer higher-level abstractions than RDDs, easing data analysis and integrating seamlessly with Spark SQL for SQL-like queries. 3. Spark SQL. Bringing the power of SQL to the big data playground, Spark SQL lets you run familiar SQL queries on data frames and RDDs. This familiar syntax makes exploring and analyzing massive datasets intuitive, especially for those comfortable with relational databases. 4. MLib. Unleash the power of machine learning with MLib, PySpark's built-in machine learning library. Packed with algorithms for classification, regression, clustering, and recommendation systems, MLib lets you train and deploy models within your PySpark workflow. 5. Spark Core. Think of Spark Core as the engine room, the distributed processing engine that orchestrates tasks across the cluster. It handles resource allocation, fault tolerance, and communication between machines, ensuring your PySpark applications run smoothly. 6. Additional components. PySpark's toolbox extends beyond these core components. Spark Streaming enables real-time data processing, Graphics tackles graph-based problems, and Data Frames API for Java Scala integration brings interoperability. Remember, these components work together seamlessly, allowing you to wrangle, analyze, and extract insights from massive datasets with ease. With PySpark, the power of big data is at your fingertips. Explore deeper. Each component deserves a deeper dive. Don't hesitate to ask for further details on any specific element of PySpark's fascinating architecture. The benefits of using PySpark. PySpark, the Python API for Apache Spark, offers a plethora of benefits for tackling big data challenges. Here are some key advantages of using PySpark. 1. Powerful parallel processing. Speed and scalability. PySpark leverages Spark's distributed processing engine to analyze massive datasets across multiple nodes, significantly boosting processing speed and handling terabits of data with ease. Efficiency. Parallelizing tasks like filtering, sorting, and aggregating data through RDDs and data frames minimizes processing time and enables efficient analysis of large datasets. 2. Python familiarity. Ease of use. The clean and familiar Python syntax of PySpark makes it beginner-friendly for Python developers without requiring them to learn a new language like Scala. Rapid development. rapidly prototype and implement complex big data processing tasks without the need for lengthy code development cycles in unfamiliar languages. 3. Rich analytics functionality. Comprehensive tools. PySpark provides a diverse set of built-in tools for data manipulation, analysis, and visualization, including data frames, Spark SQL, mlib, and plotting libraries. Flexibility. Perform various tasks like filtering, joining, aggregating, and visualizing data, train machine learning models, and extract meaningful insights from complex datasets. 4. Integration and interoperability. Seamless data access. Connect diverse data sources like HDFS, Hive databases, and other storage systems for integrated data analysis within PySpark. Works with existing tools, interoperates with Python libraries like NumPy, Pandas, and scikit-learn, allowing you to leverage existing skills and code in your PySpark workflows. 5. Open source and community-driven. Cost-effective. Being open source and having a vibrant community, PySpark offers significant cost advantages compared to proprietary big data solutions. Constant innovation. The active community keeps PySpark constantly evolving with new features, optimizations, and bug fixes, ensuring access to the latest advancements in big data technology. Overall, PySpark empowers data scientists, developers, and analysts to handle big data challenges efficiently and effectively with its powerful processing capabilities, user-friendly Python interface, and rich analytics ecosystem. From large-scale data analysis to machine learning, PySpark remains a versatile and valuable tool for unlocking the potential within your data. Key features of using PySpark. PySpark shines as a powerful tool for big data analysis thanks to its impressive features. Here are some key highlights. 1. Distributed processing. PySpark leverages Apache Spark's distributed processing engine, enabling you to analyze massive datasets across multiple nodes in a cluster. This translates to significantly faster processing times compared to traditional single-threaded approaches. 2. Scalability. PySpark scales effortlessly as your data volume grows. You can simply add more nodes to your cluster to handle larger datasets without compromising performance. 3. Resilient distributed datasets. RDDs are the fundamental building blocks of PySpark. They represent distributed, immutable collections of data that can be efficiently manipulated in parallel across cluster nodes. This ensures fault tolerance and guarantees data processing completion even if nodes fail. 4. Data frames. For structured data, PySpark offers data frames, a tabular data structure similar to Pandas data frames. They provide a familiar and intuitive interface for data manipulation and analysis, making it easier to perform tasks like filtering, sorting, aggregation, and joining. 5. Spark SQL. PySpark seamlessly integrates with Spark SQL, allowing you to write familiar SQL queries on both RDDs and data frames. This enables SQL-savvy users to leverage their existing knowledge for efficient data analysis within the PySpark ecosystem. 6. mlib. PySpark's mlib library provides a comprehensive set of machine learning algorithms for tasks like classification, regression, clustering, and recommendation systems. This empowers you to build robust machine learning models on your big data using familiar Python syntax. 7. Data visualization and storytelling. PySpark integrates with various plotting libraries like matplotlib and seaborn, allowing you to create compelling visualizations of your data. This is crucial for effectively communicating insights and telling a data-driven story to your audience. 8. Optimization and performance tuning. PySpark provides various tools and techniques for optimizing your applications and achieving peak performance. You can identify bottlenecks, analyze resource utilization, and implement tuning strategies like caching and data locality to ensure efficient execution. 9. Integration and interoperability. PySpark seamlessly integrates with other popular big data tools and technologies like HDFS, Hive, Kafka, and more. This enables you to build complex data pipelines and workflows that leverage the strengths of each platform. 10. Python ecosystem. PySpark leverages the rich Python ecosystem, providing access to a vast array of libraries and tools for various tasks like data cleaning, web scraping, and scientific computing. This significantly expands the capabilities of PySpark and simplifies the development process. These are just some of the key features that make PySpark a powerful and versatile tool for big data analysis. Its ability to handle massive datasets, offer familiar interfaces, and provide rich functionality makes it a valuable asset for data scientists, analysts, and anyone working with big data. The challenges of using PySpark. The challenges of using PySpark, navigating the rapids of big data. While PySpark offers immense power for processing massive datasets, it's not without its challenges. Conquering these hurdles is crucial for maximizing your big data journey and extracting the full potential of this powerful tool. Let's dive into some of the key obstacles you might encounter. 1. Conceptual complexity. Learning curve. PySpark's distributed processing model and APIs can be unfamiliar, requiring a significant learning investment for new users accustomed to traditional serial programming. Abstraction. Hiding the underlying distributed nature of Spark can sometimes lead to confusion, especially when debugging issues or optimizing performance. 2. Data management and access. Data sources. PySpark requires data to be accessible on distributed file systems like HDFS, which might require setting up new infrastructure or data migration. Data manipulation. Dealing with large datasets can be cumbersome, requiring careful planning and efficient data manipulation techniques to avoid performance bottlenecks. Data quality. Ensuring data quality and consistency across distributed nodes is crucial and requires robust data cleansing and validation techniques. 3. Performance and optimization. Resource management. Efficient resource allocation and cluster configuration are critical for optimal performance, and mastering these aspects can be challenging for beginners. Bottleneck identification. Identifying performance bottlenecks in distributed systems can be complex, requiring specialized tools and debugging techniques. Memory management. Large datasets can quickly consume memory, requiring careful memory management strategies and efficient data partitioning. 4. Debugging and error handling. Distributed errors. Debugging errors in distributed systems can be complex, as the source of the issue might not be readily apparent on the local machine. Logging and monitoring. Effective logging and monitoring practices are essential for identifying and troubleshooting errors in PySpark applications. Limited error messages. Error messages in PySpark can sometimes be cryptic, requiring deeper understanding of the underlying distributed processes for effective resolution. 5. Integration and security. Integration with other tools. Integrating PySpark with existing data pipelines and analytics tools can be challenging due to potential compatibility issues. Security and access control. Ensuring secure access to sensitive data within a distributed environment requires careful implementation of security measures and access control mechanisms. Version compatibility. Staying up to date with the latest PySpark versions and ensuring compatibility with other components in your data ecosystem can be a continuous challenge. Beyond the challenges. While these challenges may seem daunting, remember that PySpark is a powerful tool with a vibrant community and extensive resources available. By dedicating time to learning, experimenting, and leveraging community support, you can overcome these hurdles and unlock the vast potential of PySpark for your big data needs. Setting up your environment. Setting up your PySpark environment, a comprehensive guide. Mastering PySpark opens doors to the world of big data analysis. But before you dive into the exciting realm of RDDs and data frames, you need to set up your development environment. This guide will walk you through the steps, ensuring a smooth and efficient PySpark journey. 1. Prerequisites. Python. Install a recent version of Python 3.7 plus recommended. Choose a stable release for production environments. Java. PySpark leverages Java, so ensure you have a JRE Java runtime environment installed. Apache Spark. Download and install the latest stable version of Apache Spark for your operating system. Optional. Additional libraries like Pandas, NumPy, and Matplotlib can enhance your PySpark experience. 2. Installation options. Pip. The simplest method is using pip install PySpark. This installs the PySpark package and its dependencies. Conda. If you use Conda environments, create a new environment and install PySpark within it. This allows for better dependency management. Manual installation. Download the PySpark binary for your platform and configure it manually. This offers more control but requires more technical knowledge. 3. Setting up the Spark environment. Spark configuration. Edit the sparkenv.sh file in your Spark installation directory to set environment variables like spark_home and hadoop_conf_dir. Cluster configuration. Optional if using a Spark cluster. Configure the cluster details in sparkdefaults.conf or through environment variables. 4. Testing your installation. Start the Spark shell. Run Spark shell to launch the interactive Spark shell. Import PySpark. Type import PySpark within the shell. If successful, you're ready to code. 6. Advanced tips. Virtual environments. Consider using virtual environments, WANV or Conda environments, to manage dependencies and isolate projects. IDE integration. PySpark plugins are available for popular IDEs like PyCharm and IntelliJ IDEA for enhanced development experience. Cloud platforms. Explore cloud platforms like AWS EMR or Azure HD Insight for convenient and scalable Spark deployments. Data visualization and storytelling. Transforming data into captivating narratives. Data visualization and storytelling with PySpark. PySpark isn't just about crunching massive datasets, it's about unlocking actionable insights and conveying them in a way that resonates with your audience. That's where the magic of data visualization and storytelling comes in. This guide will equip you with the tools and techniques to craft compelling narratives that transform complex data into captivating experiences. 1. Choosing the right visualizations. Know your data. Different types of data call for different visualization styles. Understand the relationships, trends, and patterns within your data to choose the most effective visual representation. Consider your audience. Are you presenting to data experts or novices? Tailor your visualizations to their level of understanding and avoid overwhelming them with unnecessary complexity. Variety is key. Don't get stuck in a bar chart rut. Explore diverse options like pie charts, scatter plots, heat maps, and interactive dashboards to keep your audience engaged. 2. Mastering PySpark visualization libraries. pyplot and Matplotlib. These fundamental libraries offer a wide range of basic plotting functions for line graphs, histograms, and scatter plots. Learn to customize colors, labels, and titles for clear communication. Seaborn. Build upon Matplotlib with advanced statistical visuals like violin plots, box plots, and heat maps. Leverage Seaborn's color palettes and aesthetics for elegant and informative data representations. Plotly and Bokeh. Create interactive visualizations that allow users to explore data intuitively. Utilize features like zooming, panning, and tooltips to empower your audience to discover insights on their own. 3. Storytelling with data. Start with a question. Frame your analysis around a specific question or hypothesis. This will guide your data exploration and ensure your visualizations tell a focused and meaningful story. Emphasize clarity over complexity. Prioritize clear communication over flashy design. Use concise labels, descriptive titles, and appropriate color palettes to avoid confusing your audience. Highlight key findings. Don't overload your visuals with too much information. Identify the most impactful insights and emphasize them through visual cues, annotations, or callouts. Add context and narrative. Surround your visualizations with a compelling narrative that explains the data's origin, methodology, and implications. Use text, annotations, and even storytelling techniques to capture and hold your audience's attention. 4. Advanced techniques. Animation and transitions. Breathe life into your visuals with animations and transitions that showcase data trends and changes over time. Interactive dashboards. Build interactive dashboards with PySpark and Plotly Bokeh to allow users to filter, query, and explore data on their own terms. Machine learning insights. Visualize the outputs of your PySpark machine learning models. Use techniques like decision tree visualizations and feature importance plots to explain model behavior and gain deeper understanding. 5. Resources and inspiration. Explore online galleries. Platforms like Tableau Public and Data.World showcase data visualizations created by experts. Use them for inspiration and to learn from best practices. Take online courses. Invest in online courses or tutorials focused on data visualization with PySpark. Learn from experienced instructors and hone your storytelling skills. Get feedback and iterate. Share your visualizations with colleagues, peers, or even a broader audience for feedback. Continuously refine your storytelling approach and learn from constructive criticism. Optimization and performance tuning. Here are key points for optimizing and tuning PySpark applications, explained in simple terms. 1. Know your data and operations. Analyze data, understand its size, structure, and distribution to make informed decisions. Focus on expensive operations. Identify the most time-consuming parts of your code for targeted optimization. 2. Choose efficient data structures. Prefer data frames. They offer more structure and optimizations compared to RDDs. Use the right data types. Select appropriate types, example, integers instead of strings, for efficient storage and processing. 3. Minimize data transfers. Collocate data and computations. Ensure data is processed on the same nodes where it's stored for faster access. Cache frequently used data. Store it in memory for quick retrieval in subsequent operations. Consider partitioning. Divide large datasets into smaller chunks for parallel processing and reduced data shuffling. 4. Tune Spark configuration. Adjust memory allocation. Allocate appropriate memory for Spark executors and storage needs. Optimize level of parallelism. Determine the optimal number of partitions and tasks based on your cluster resources and workload. 5. Improve code efficiency. Minimize transformations. Reduce the number of operations on data frames or RDDs, as each transformation creates a new dataset. Use vectorized operations. Employ vectorized UDFs and built-in functions for faster numerical computations. Consider lazy evaluation. Spark delays computations until necessary, allowing for optimizations. 6. Monitor and profile. Use Spark's web UI, track job execution, resource usage, and identify bottlenecks. Profile code. Use profiling tools to pinpoint slow code sections for optimization. Additional tips. Experiment with different approaches. Find what works best for your specific workloads and environment. Stay updated. Keep pace with new features and advancements in PySpark and Spark for potential performance improvements. Explore advanced techniques. Consider techniques like broadcast variables, custom partitioning, and data compression for specific scenarios. Best practices and implementation strategies. PySpark, big data done right, best practices made easy. Taming big data can be messy, but fear not. PySpark can be your secret weapon, but using it effectively takes some smarts. Here are some simple best practices and implementation strategies to make your PySpark adventures smooth and successful. 1. Setting up for success. Get comfy with your environment, whether local machine or cloud. Make sure PySpark and your data sources, like databases, are pals. Organize your playground. Keep your code clean and well-structured with folders and files. Know your resources. Understand how much memory and processing power you have, and don't try to be a data hero by overloading. 2. Data Wrangler Extraordinaire. RDDs are your building blocks. Learn how to create and manipulate these resilient distributed datasets for efficient parallel processing. Data frames, your structured BFF. Master working with data frames for querying, filtering, and analyzing your data like a pro. Spark SQL familiar friend. Use SQL's familiar syntax to query your data within PySpark. No need to learn a whole new language. 3. Machine Learning Magic. MLib is your ML toolbox. Use PySpark's built-in machine learning library to train algorithms for tasks like predicting future trends or recommending products. Start simple, then go wild. Begin with basic algorithms like regression or classification, then graduate to more complex models as you get confident. Data is king and queen, remember, garbage in, garbage out. Clean and prepare your data properly before feeding it to your algorithms. 4. Performance Powerhouse. Optimize like a champion, identify bottlenecks, and tune your code for efficient execution. Caching, data locality, and resource allocation are your friends. Monitor and troubleshoot. Keep an eye on your PySpark apps with built-in monitoring tools and dashboards. Fix issues before they become monsters. Cloud is your ally. Consider deploying your PySpark applications on the cloud for increased scalability and automatic updates. Just remember security and compliance. 5. Staying sharp. Practice makes perfect. Work on real-world projects and challenges to hone your PySpark skills. Community is key. Connect with other PySpark users online, share best practices, and learn from each other. Keep learning. New tools and techniques emerge all the time. Stay updated and keep your PySpark knowledge fresh. Cloud deployment and advantages. Imagine you have a pile of books so big it fills your whole house. Analyzing them all by hand would take forever. That's where PySpark comes in, like a super-powered librarian. It helps you crunch through giant datasets on multiple computers at once, giving you insights you wouldn't even dream of before. But where do you keep all these super-powered librarian computers? That's where the cloud comes in, like a giant library in the sky. By deploying PySpark on the cloud, you get more space, no need to fill your house with computers. The cloud has all the storage and processing power you need, wherever you are. Faster analysis, more computers working together means quicker results, even for the biggest datasets. Easy access, anyone with an internet connection can access your analysis, making collaboration and sharing a breeze. Flexible scaling, need more power for a huge project? No problem. Just scale up your cloud resources in a snap. Don't need them anymore? Scale down and save money. Automatic updates, no more worrying about keeping your software up to date. The cloud takes care of everything, freeing you up to focus on what matters. Cost-effective, you only pay for what you use, unlike buying and maintaining your own hardware. Think of it this way, cloud deployment is like renting a powerful computer in the sky. and PySpark is the super-powered librarian living there. Together, they can help you analyze any mountain of data and unlock valuable insights that were once hidden in the stacks. So, ditch the piles of books and head to the cloud library. PySpark and the cloud are waiting to help you conquer your biggest data challenges. The future of PySpark. PySpark's future, brighter than ever. Imagine PySpark as a superhero, constantly evolving and getting stronger. That's what's happening. Here's a glimpse into its exciting future. Even faster and more efficient, PySpark will fly through even bigger datasets, crunching numbers at lightning speed. Think faster answers, quicker insights, and happier data analysts. Easier to use, just like Iron Man's slick suit, PySpark will become even more user-friendly. Beginners can join the party, and seasoned pros can code like lightning. Smarter tools, expect intelligent features that automatically optimize tasks, recommend solutions, and help you avoid coding headaches. Think of it as Jarvis for your data analysis. Cloud-powered, PySpark will embrace the cloud, becoming even more accessible and scalable. No more expensive hardware, just spin up clusters in the cloud and get cracking. Machine learning magic, PySpark will become a machine learning powerhouse. Imagine building complex models with a few lines of code and unlocking hidden patterns in your data like a true data sorcerer. More than just Python, while Python will remain its best friend, PySpark will open its doors to other languages like R and Scala, making it a truly inclusive data playground. Overall, PySpark's future is brimming with possibilities. It's becoming simpler, smarter, and more powerful, ready to take the big data world by storm. So buckle up, data enthusiasts, the ride is going to be amazing. Salary and career opportunities in PySpark in India. PySpark in India, big dreams, bigger paychecks. Learning PySpark, the Python powerhouse for big data, opens doors to exciting careers and juicy salaries in India. But how exciting and juicy are we talking? Let's unpack the potential. Salary scope. Freshers, starting with around 4 to 6 rupees lakhs annually, expect your pay to jump as you gain experience. Mid-level, with 3 to 5 years under your belt, aim for 7 to 12 rupees lakhs. Hone your skills, and 15 to 20 rupees lakhs could be reachable. Senior level, experienced PySpark masters can command salaries exceeding 20 lakhs rupees, with senior architects potentially reaching 40 lakhs rupees or more. Career opportunities. Data analyst scientist, analyze big data to solve real-world problems in diverse industries like healthcare, finance, and e-commerce. Big data engineer, build and maintain the infrastructure for efficient big data processing using PySpark. Machine learning engineer, develop and deploy powerful AI models using PySpark's MLib library. Data architect, design and implement scalable data solutions powered by PySpark. Demand and growth. India's big data market is booming, and PySpark is a key driver. This translates to high demand for skilled professionals, especially those with cloud expertise. Companies like Flipkart, Ola, and Reliance are actively seeking PySpark talent, offering exciting opportunities and competitive salaries. Getting started. Master the basics of Python and big data concepts. Invest in online courses and certifications to sharpen your PySpark skills. Build a portfolio of projects showcasing your abilities. Network with professionals in the big data field. Why choose PySpark Online Training? Learning PySpark Online is like getting superpowers for crunching huge amounts of data. Here's why it's awesome. Master big data. Imagine tackling mountains of info with ease. PySpark lets you analyze massive datasets lightning fast, unlocking all their hidden secrets. Python power. Already know Python? Awesome! PySpark uses Python, so you can level up your skills without starting from scratch. Fast and scalable, forget waiting forever for results. PySpark processes data on multiple computers at once, giving you answers in a blink. Machine learning magic, build powerful prediction engines, and uncover hidden patterns in your data. PySpark even has fancy tools for robots that learn on their own. In-demand skills, companies everywhere need PySpark wizards. Learning it online opens doors to exciting new career opportunities. Flexible learning, forget rigid schedules. Choose online courses that fit your life, whether it's late-night coding sessions or weekend learning marathons. Cost-effective, online training lets you learn from top experts without breaking the bank. No fancy travel or classroom fees, just pure knowledge delivered straight to your screen. Thriving community, get stuck? No worries. Online communities and forums connect you with fellow PySpark learners and pros ready to help. Stay updated, the world of big data moves fast. Online training keeps you on top of the latest trends and tools, making you a future-proof data guru. Future-proof career, the future belongs to those who can handle big data. Mastering PySpark Online gives you a head start and sets you up for success in the data-driven world. So, why wait? Unleash your data crunching potential with PySpark Online Training. Why choose Proexcellency PySpark Online Training? Here are some reasons why you might choose Proexcellency's PySpark Online Training, in simple terms. Focus on what you need. They offer hands-on, practical training that goes beyond theory and lets you get your hands dirty with real-world PySpark projects. Experienced trainers. Their trainers are PySpark experts who have worked in the field, so they can answer your questions and share valuable insights. Flexible learning. You can take their courses online at your own pace, which is great if you have a busy schedule. Cost-effective option. Their courses are competitively priced compared to other options, so you can get quality training without breaking the bank. Additional benefits. They offer career guidance and placement assistance to help you land a job in the big data field. They provide a supportive learning community where you can connect with other PySpark learners and professionals. Overall, Proexcellency seems like a good option if you're looking for a practical, affordable, and flexible way to learn PySpark from experienced professionals. Contact us. 0803150868 vertical bar +919008906809. www.proexcellency.com. Infoproexcellency.com @proexcellency.com. Thank you for all attention.